have to have a variable in the denominator. The 2 plus x over 5 is actually a linear function. So if I put an x here, now it is a rational function. 3x squared minus 1 over x is also, these are all examples of rational functions. That's function notation. Now, give me another example. Somebody else give me another example of a rational function. Make something up. No? Rational function. Come on. I'm not talking tonight. Computer isn't working. My allergies are hurting. Like allergies are hurting, but my head's hurting. So give me an example of a rational function. Thank you. X plus 5 over x squared. Now, we also need to know, especially on a test, give me an example of a rational expression and a rational equation. Later on in chapter 5, we're going to solve rational equations. Now, what's the difference between a rational equation and a rational expression? Well, a rational expression is just that, an example. It's an expression, while a rational equation has what that the other one doesn't. Has an equal sign and it's equal to 5. I just made that up. So keep that in mind because these are easy questions on the test. Give me an example of a rational expression. Just look at the test. The whole test is about rational expression. Just copy one. And I'm sure there's a rational equation that you have to solve. Every time where it says solve, these are equations. So the difference here is the equal sign, of course. Now, this is just the explanation you see in the book. A rational function has the form where you have, basically what it means is you have a polynomial in the numerator and one in the denominator. So here's one from the book. Here's a rational function. F of x is x plus 2 over x minus 3. I want you to find f of 1, f of 0, and f of 3. Again, we have done this in chapter 3, I think it was, when we briefly talked about functions. So if I ask you to find f of 1, what does that mean again? I forgot. Chapter 3 has been a long time.
That means that you plug 1 in for x.
Right. Every time in your function you see the x, you plug in a 1. So 1 plus 2 over 1 minus 3. And then you do the arithmetic in the numerator. 1 plus 2 is 3, and 1 minus 3 is negative 2. Done you are. What is f of 0? F of 0. Now you're going to go ahead, you go back to the original function and you replace your x with 0. 0 plus 2 over 0 minus 3 is what? Negative 2/3, or 2 over negative 3. Where you put the negative, it doesn't really matter as long as you put it there somewhere. Now that f of 0 is negative 2/3. That point has a special name. How's that called? What kind of point is that? If you were to graph this function, the y-intercept. This point would be 0, negative 2/3, and that is called the y-intercept. What is f of 3? 3 plus 2 over 3 minus 3. 3 plus 2 is 5. 3 minus 3 is 0. 5 over 0 is considered to be what? Nope. Nope.
Infinity?
Nope. Well, sort of. It's undefined. You cannot have a 0 in the denominator. I think we talked about that when we tried to figure out what the domain of this rational function is. This rational function is undefined. It doesn't have a y value at 3. You can never, ever, ever have a 0 in the denominator. Does anybody remember now that we know, I called this the restricted value, the RV is equal to 3. Who remembers what the domain is of this function? How did we write that? Nobody. So this function is defined for all real numbers except for 3. This would be the domain in words. In symbols, we have to write it in interval notation. Okay, Luke, we're getting somewhere. Negative infinity to...
With the greater than?
No. Negative infinity to 3, parentheses, meaning that the number is not included, union 3 to infinity. This would be the interval notation. So let's say here's 3. We have y values for everything to the left of 3 and every value to the right of 3. The number 3 itself is bad because the function is not defined at 3. So you go first from negative infinity to as close to 3 as you can. That's why we write it in parentheses. Then you jump over the 3. You replace your x in the original problem with negative 6 first. Negative 6 minus 4 over negative 6 plus 6. What do you get for m of negative 6? Undefined. Negative 10 over 0 is undefined. So that tells us that the restricted value is x equals negative 6. M of negative 4. Negative 4 minus 4 over negative 4 plus 6 is negative 8 over 2, which would be negative 4. Right? 0 minus 4 over 0 plus 6 is negative 4 over 6. Now that can be reduced to negative 2/3. And what is m of 4? I was just thinking, if anybody's interested on Thursday coming early, I can be here early at 6-ish. Yes, anybody?
This Thursday.
Yeah. So 4 minus 4 over 4 plus 6, that would be 0 over 10, which is 0. Right. Okay, so we know at which value this function is undefined. That means the restricted value is -6. How do we write the domain down now? Domain is, Luke, you said before. Oh no, you said it wrong. Say it again. Negative
infinity,
2,
-6,
6, union the
-6
6 to infinity. Right. Yep. Now if we only have one restricted value, then that is your domain. In the general form, I'm gonna write that down in a second. So if I don't give you any values and you have to find the domain, then how do you do that? You set the denominator equal to 0. That's just the definition for the domain of a rational function. Again, it's not defined for the restricted value that makes the denominator equal to 0. A linear function like y equals mx plus b always has a domain of -infinity to infinity. That will never change. The domain of a linear function stays the same no matter what. However, the domain of a rational function depends on the denominator only. Don't look in the numerator. How many students always look in the numerator? Too many. So here's a problem. Looks pretty intimidating. F of x equals x squared plus 2x minus 6 over x plus 5. To find the domain, the first step is to set the denominator equal to 0. What is the denominator here?
x plus 5.
Right. So we take the x plus 5 and you set it equal to 0. First step. The second step is to solve this equation and find the RV. So subtract 5 from both sides. X equals -5. That now is your RV. And that's all you need to find the domain. The domain, when you only have one RV, the general form is -infinity to whatever value the RV is, union RV to infinity. That's kind of the general form for one RV. We're about to do a problem where we have more than one. Ooh. So what's the domain for the pink one? -infinity to
-5.
union -5 to infinity. If you get this down pat now, college algebra is a breeze. I want to say college algebra is easier than intermediate algebra. So Garrett, what happened to your hair? You cut it? Obviously, yeah.
Yeah, it kind of fell off.
Oh, it fell off?
Yeah, I got in the shower.
Oh, and it was gone. Wow.
One thing lived in there and just kind of happened.
I like it. I like the other way too. I just see you from the back looking at your hair. Okay, next problem. Number 10. P of t equals t plus 9 over t plus 3. What is the RV? What is the domain? You do it. Other than Luke, he's done enough domain this evening. You set the t plus 3 equal to 0. That means your restricted value is what?
-3.
-3. Everybody with me? Taylor, yes?
Yes.
Okay, now what's the domain, Taylor?
Negative infinity, -3. Union, -3, positive.
Beautiful. There you go. That's it. Now don't forget that until next week. Or whenever we have a test. Okay, now here comes, I keep talking about it, what happens if we have more than one RV? Number 17, the denominator is x squared minus 25, and you're going to have to set that equal to 0. Well, the only way for now, how we know how to solve this equation is by factoring. This is a quadratic equation. Matter of fact, it's a difference of two squares. How do we factor x squared minus 25?
Separate, split it in 3 things.
We did x minus 5, so then we took the 2 in the middle. That's an x minus 5, one factor, and the other factor would be x plus 5. In chapter 5, I told you must know how to factor, and specifically, you should remember or practice how to factor differences of squares. There's a bunch of differences of squares. There's also just some common GCF factoring and a trinomial here and there. So the factoring isn't really hard. You won't see a cube there are not few problems where you have to factor a cube. It's mostly really difference of squares. So with that, we now set each factor equal to 0. And we solve for x, and you get x equals 5, and you get x equals -5. So in this case, you have two RVs. For 5 and -5, this function is not defined. On a number line that looks somewhat like this, -5 and 5. Now, our function has a domain that's good on the left side, then we have in between, and then we go on the right side. So if we have two RVs, we have a 3-part domain. There are 3 parts to the domain. The -5 is bad and the +5 is bad. So the domain would be, does anybody want to try?
Negative infinity to -5 union, -5 to 5 union, 5 to positive infinity.
You got it. Beautiful. Here you go. So a 3-part domain. The general form, I guess, that's the general. The general form would be more or less -infinity to RV1 union RV1 to RV2 and union RV2 to infinity. And of course, we're going with the smaller value first, from left to right. We don't have any other domain like 4 or 5 parts. We don't do this. X squared is the highest exponent we look at. Cool, I like it. So there are some, I don't want to do this here. We know now what the domain is. You can look at, I don't want to do this one either. Now, I want to give you a domain and you give me a function. So the domain is negative infinity, 7, 7 to infinity. What would be an example of a function that has that domain? And it should be 10 different answers. I'm happy with one. Give me an example of a function where we have the given domain. Definitely something over something.
2/3.
2/3. Where's that coming from? You have a domain of negative infinity to 7. A 3 isn't going to work. X minus 7 in the denominator. Thank you. What do you want to put in the numerator? What? Oh, give me something. X squared plus 1? Sounds good to me. Here you go. Look, you see? Yeah. So the denominator has to have the opposite sign of whatever the domain is. The denominator has to be the opposite sign. Another possible example, Luke, you want to try this again? Okay, go for it. It's definitely an x minus 7 in the denominator. What do you want to put in the numerator? Here you go. The easiest problem of them all. 1 over x minus 7 is an example. Yes? These are questions I've seen on tests before. How about this one? Last one. The domain is given. Give me a function.
X over x plus 2.
X over x plus 2. That is correct. F of x equals 1,567,000 over x plus 2. Why not? I just made that up. F of x equals 17x to the 11 minus 3x to the 9 plus 15x to the 8th plus 2x to the 6th plus x to the 5th plus, why they all plus, 6x to the 3rd minus 2x squared minus x plus 1 over x plus 2. They all have the same domain. It doesn't matter what is in the numerator as long as you have an x plus 2 in the denominator. Okay, now you don't have to graph it, but just there were some graphs in the book, and I just wanted to point out whatever the RV is, that's where the graph has a gap. So because I'm jumping over the -4 in this case. So what you will learn how to graph them in college algebra. We don't have to graph them in intermediate algebra. That gap, so what we do is we draw a vertical line at x equals -4 in this case, and that's called an asymptote. You have a vertical asymptote at x equals -4. And then the graph, there's a piece on the left and a piece on the right-hand side. But this is an example of a graph, and that's how they look like. We don't want to do that again. We just did that. So now we're getting to the reducing part and getting into the rational expressions. But let's just look at fractions. 2 over 8, how can we reduce that?
1 over 4.
That would be 1 over 4. We're kind of doing it in our head because that's a fraction we're familiar with. But really what you did was, in not so many words, you divided by 2, or you factored the 2 into 2 times 1 and the 8 into 2 times 4, and then you can reduce the 2 over 2, which is 1. We don't say cancel anymore. If you say cancel, you have to sing or something. I'm the only one who's allowed to say cancel. We're not canceling it because look, we cross this out and it goes away. It doesn't go away. It reduces to 1. If you have the same numerator over the same denominator, that always reduces to 1. 3x over 3x, x over x is 1. X plus 1 over x plus 1 reduces to 1. What about 25 over 35?
5 over 7. Take the greatest common factor out.
5 over 7, so 25 is 5 times 5, and 35 is 5 times 7. If we reduce it, that ends up being 1, then we get Will is right, 5 over 7. Now, I also want to highly encourage you to write these ones down, because sometimes you have to reduce, like the 2 over 8. How many times students write a 4 instead of a 1/4? 8 divided by 2 is 4. No, it's 2 over. So be careful about that. How about this one? Am I allowed? 2 goes into 4 twice, and 3 goes into 6 twice, and nothing on top. The answer is 4. Am I allowed to do that?
You gotta add
What did I
first.
just do? I don't even know what I did, but it was just totally wrong. You are not ever, and this is the biggest mistake in chapter 5, to reduce when there's a plus or minus in between. You can only reduce if it is multiplication. Now we can go ahead. 3 goes into 6 twice. 2 goes into 4 twice. And the answer would be 1/4. If there's multiplication, you can do that. If there's addition or subtraction, you have to add your numerator first, which is 5 over 10. And now, and only now, you are allowed to reduce. 5 over 10 is what? 1/2. But you can, this goes into 3, and this is 1, and just totally wrong. However, students want to do that, especially with factors that have a variable in there. Don't do that. 32, I don't know what 32 is. So let's go to 37 because I have it right here. So now we're starting to learn how to simplify, and we're simplifying rational expressions. And when you see the word simplifying in the book, that means reduce. We are reducing rational expressions. And again, 6 and 27, they have a 3. Let's just cancel out a 3 and a 9 and life is good. No. I wrote the steps down. The first step is to factor numerator and denominator. There are pluses in between, and pluses between pluses you are not allowed to cancel. Yeah, I said the word. So you have to factor the numerator and the denominator first. How do we factor the numerator? GCF is 6. It's a plain, simple GCF factoring problem. What's in the parentheses? A plus 3. Okay, now we got to factor the denominator. 9a plus 27. What can you factor out here?
9.
A 9. And in parentheses is a plus 3. You must factor first. Now step 2, reduce common factors. There's an S missing, maybe. to 1. Common factors meaning the same factors in the numerator and in the denominator. Obviously, we have a common factor here, which is a plus 3. So that a plus 3 is reduced to be 1. And now we're going to check and see if we can simplify further, because what we have left here is 6 over 9. And 6 over 9 can be reduced by 3. And the final answer is 2/3. And you say that, oh, I got that if I just look at 6 over 9 in the front. Is that always like this? Whatever the first two numbers are? No, it's not always like that. Don't even think about it. And that's how we simplify. Factor. And you see how factoring is important. Are you ready for the next one?
So if it doesn't turn out like step 2 did, do we just stop there?
Yes. Good point. Okay. If this would have been 5 over a plus 4 over 3 over a plus 3, there is nothing you could have done to reduce it. This cannot be reduced whatsoever. Good point. Yes. And I'm sure there's a problem, something similar. Let's take a look at 38. 5y minus 15 over 3y minus 9. Again, the factoring is, I'm going to say simple factoring. That is the kind of difficulty of factoring that you need to know. And if you don't know it, you got to practice it. 5y minus 15, how do you factor it? Factor out of 5, and you have a y minus 3. GCF, that's all you can do. The denominator factors into a 3. Oh, here you go, there's a 5/3. Y minus 3. So now you go ahead. The common factor, reduce that to 1. And the answer here is 5/3. It's not hard, I hope. Go ahead and do 39. Now, x minus 5 in the numerator, I'll help you with that one. This cannot be factored further, so you just copy it over. You can't factor x minus 5. It's just. But the x squared minus 25, we factored that earlier. Difference of squares, x minus 5 and x plus 5. Okay, somebody tell me what the answer is.
X plus 5.
Ah, I knew it. Thank you for saying that. What did I say earlier? I highly recommend to put the ones down. X minus 5 over x minus 5, that reduces to 1. 1 here, 1 there. Now you want to change your answer?
1 over
Thank you.
x plus 5.
1 over x plus 5. Don't forget that. That is another common mistake in this chapter. Oh, they cancel each other out. Oh, they're gone. It's just an x plus 5 left. And that's wrong. Okay, now we have a little bit more involved. So these are trinomials, number 44. Luckily for us, these trinomials have a leading coefficient of 1, and when that is the case, you can just make your 2 parentheses. And we have a y here, y here. Find 2 numbers that multiply to -9, but at the same time add to 8. 9 times negative 1. Okay.
No.
Yeah. Plus 9 minus 1. And in the denominator, we need a 4 multiplied and a negative 5 added. Which two numbers multiply to 4, but at the same time add to a negative 5?
Negative 4, negative 1.
Negative 4 and negative 1. Now, 9 out of 10 times you get a problem where you can reduce something, because otherwise we wouldn't give you the problem. So always, if you did the top already, then the bottom's got to look somewhat similar, or at least one factor's got to be the same. So we have a common factor, the y minus 1, they reduce to 1, and all what is left is y plus 9 over y minus 4, and nothing else can be done. I don't want to do this one before time is up. I want to talk about subtraction. Now, we know, look at this purple one here, expression. X plus 2 and 2 plus x. Addition is commutative. In other words, if you change the order of an addition problem, it really doesn't matter. You still have the top and the same in the numerator as you have in the denominator, so that's equal to 1. When you reduce it. Does that hold true for subtraction?
No.
No. So let's take a look at 2 minus 3. What is 2 minus 3? Negative 1. What's 3 minus 2?
1.
Positive 1. So here's something you got to remember. When you have a difference or subtraction, and the order is reversed, that always reduces to a negative 1. X minus 2 over 2 minus x, negative 1. 4 minus 2 over 2 minus 4, negative 1. 3 minus x squared over x squared minus 3, negative 1. So we cannot just reduce it to 1, we have to reduce it to negative 1. Let's take a look at an example. Number 60. 5p minus 10 over 2 minus p. Again, the factoring should be easy. 5p minus 10. GCF. What is a GCF? 5. So you factor out a 5, and that means you have a p minus 2, and the denominator cannot be factored. It's a 2 minus p. Now, what did I just say? They reduce, the order is reversed, so I'm telling you what you need to do in this case. They reduce to negative 1, and you want to put the negative 1 always in the numerator. So cross them out and put a negative 1 here. Put it in the numerator because then it's easy to just multiply whatever you have left. You have a 5 and a negative 1, which is a negative 5. But you gotta reduce it to a negative 1. What else do we have here? Let's see if I have... No, I don't want to do this one. I just saw one. How about number 72? 72 is p squared minus 49 over 14 minus 2p. And then we're gonna, time is almost up. I want to multiply. P squared minus 49. How can we factor that? P squared minus 49. Come on.
Square root.
The difference of squares, right? P minus 7, P plus 7. How do you factor 14 minus 2p? GCF is 2. And that means you have a 7 minus p left. Now what? What can we reduce? The p minus 7 with the 7 minus p, that reduces to a negative 1, and that's really all we can do. So your answer is, and keep it like that, just like you see it, negative 1 times p plus 7 over 2. If you distribute the negative 1, it's not wrong, but keep it in factored form, because we need that later. Okay, let's take a look at a multiplication problem, one for the road. What time? Oh, we can do 2 for the roads. 1 multiplying and 1 division. I don't want to do this one. I want to look at... yeah. How about this one? 3x minus 15 over 4x squared minus 2x times 10x minus 20x squared over 5 minus x. Ooh, there's some serious factoring going on. But not difficult factoring. It's GCF kind of factoring. So this is a multiplication problem. How do we multiply two fractions? Well, we'll see if we can reduce something. And then we multiply numerator times numerator and denominator times denominator. But first you have to factor. Factor everything. You gotta factor each numerator and each denominator. How do you factor 3x minus 15?
GCF
3x minus 5. What is the GCF of 4x squared minus 2x? 2x minus 1. That is correct. It's just GCF factoring. Times, what is the GCF of the top, which is 10x, and you get what? 1 minus 2x, right? Over 5 minus x. Now I have factored everything. What can I reduce? The x minus 5 and the 5 minus x reduced to negative 1. The 2x minus 1 with the 1 minus x, 2x, that also reduces to negative 1. Am I done, or can I reduce more? The 2x, this x goes against that x, so that's 1. And the 2x, right, Taylor? 2 goes into 2 once and into 10 5 times. You are allowed to reduce that because that's a multiplication. And I think that's all we got now. So we have a 3, let me circle it, a -1, a 5, and a -1, which is a positive 15. Oh, that's it, right? 15 is our answer. Yep. Over 1. Cool. Okay, got time for one more. Real quick. How do we divide fractions? Who remembers? 1/2 divided by 3/5. You divide a fraction by changing the division to times what? The reciprocal of the second fraction in this case. And I will explain that a little bit more on Thursday. I want to do one division problem. Are you ready? Yes. Here. Oh no, that's a cube. I don't want to do cube. One division problem number 27 on page 393 is 6p plus 7 over p plus 2 divided by 36p squared minus 49. Now, first of all, rule of thumb, when you don't see a denominator, it is understood to be over 1. So this is a division problem. We're going to rewrite it into multiplication. 6p plus 7 over p plus 2 times, who can tell me times what?
1 over 36p squared minus 49.
Right, 1 over 36p squared minus 49. And now we have to see what we can reduce by factoring. The 6p plus 7 cannot be factored. The p plus 2 cannot be factored. The 1 cannot be factored. The only factoring we have to do is in the denominator. 36p squared minus 49 factors into 4 times 4 is 16. 6. 6p plus 7 and 6p minus 7. So I just copied this down here. Difference of 2 squares again. The majority of factoring this evening was difference of 2 squares. Now we can reduce 6p plus 7 with 6p plus 7. And what do we have left? What is our answer? And then we can go home. What's in the numerator?
1.
A 1. Thank you. What's in the denominator?
3 plus 2.
Times 6p minus 7. You do not have to multiply them. You just leave them in factored form. Done you are. Practice your factoring. Have a good evening. Any questions? Anything?